When we draw free body diagrams, we're only looking at one object out of a system. Here I have 3 different bricks piled on top of each other, all sitting on the ground. So if I want to draw a free body diagram, I need to be specific about what I'm drawing the free body diagram of. So first I'm going to do one for the top brick, and then I'll do one for the bottom brick. For the top brick, we have a force due to gravity, and that's going to be equal to 2.5 times 9.8. So the mass times acceleration. And then the second brick is pushing upward on the top brick in an equal and opposite force. Ideally, these two arrows are exactly the same. And when we do that on our calculator, we get that the force due to gravity is 24.5 newtons downward, and the normal force pushing up on that top brick is going to be 24.5 newtons pushing upward. Now, the bottom brick is a little bit different because the bottom brick has the weight of 2 other bricks on it. So here, it has some sort of applied force on it from the top 2 bricks. And I'm going to try to make my arrows a little bit longer to show. So my F of A is going to be my applied force from the top 2 bricks. And then we will also have a force due to gravity for the third brick itself. Now, the normal force that the floor is exerting on this bottom brick has to equal the sum of the 2 vectors going down. So if I try to make that kind of proportional, it would be something like that. The normal force from the ground. Okay, so let's put some values on these. We know that the force of gravity for just the bottom brick is going to be 24.5 newtons. And the applied force from the 2 bricks above it will be twice 24.5. In other words, it's going to be equal to the weight of those top 2 bricks. So if this is this should be 49. If this is 24.5 and this is 49, then the normal force is going to be those 2 added together. And that's 73.5 newtons. So I can go ahead and fill those values in. So my applied force from the top 2 bricks is 49. My force due to gravity from just the brick itself is 24.5. And then that normal force pushing back up has to equal the sum of the 2 pushing down. Because remember, these bricks are not flying off the ground or plunging through the floor. They are at rest, and so there has to be no net force acting on them. So that normal force moving upward is 73.5 newtons, these 2 added together.